In this video we're going to learn how to solve the Cauchy problem, i.e. the problem with the given initial conditions for the non-homogeneous second-order constant coefficients differential equation. And here it is. Y double prime plus y prime plus y equals sine squared of x. And the initial conditions are y of 0 equals 1 and y prime of 0 equals -9/2. It is known that the solution to such equations is found in the following form. Y equals y sub 0 plus y sub p, where y sub 0 is the solution to the corresponding homogeneous equation and y sub p is the particular solution to the given non-homogeneous equation. So our plan is the following. First we're going to solve the corresponding homogeneous equation to find the y sub 0. Then we're going to find the particular solution to the given non-homogeneous equation. And then finally we'll apply the initial conditions. So off we go. So first of all, we're solving the corresponding homogeneous differential equation. So it goes y double prime plus y prime plus y equals 0. To solve an equation like this, we first need to form its so-called characteristic equation. And to do this, we need to make a substitution denoting y as e to the power of rx. We're also going to need its first and second derivatives. So we go y prime equals r times e to the power of rx, and y double prime equals r squared times e to the power of rx. Now let's substitute these into our equation. So we go r squared times e to the power of rx plus r times e to the power of rx plus the single e to the power of rx equals 0. We can divide the whole equation by e to the power of rx and obtain a simple quadratic equation: r squared plus r plus 1 equals 0. And the roots of this equation are found as -1 plus or minus square root of 1 minus 4 divided by 2, which equals -1 plus or minus square root of -3 over 2. Now obviously this equation doesn't have any real roots, but it does have the complex roots, and they are the following: -1 plus or minus I times square root of 3 over 2, or we could write it as -1 second plus or minus I times square root of 3 over 2. This way we're splitting the real part of the roots from the imaginary part. So these are our characteristic roots. Let me write them in the top. So we have r sub 1 and sub 2 equal to -1/2 plus or minus I times square root of 3 over 2. We're going to need them further. And by the way, I equals square root of -1 and is called the imaginary unit. the characteristic roots, we can now write the solution to the homogeneous equation we have. And it goes like this. Constant, let's name it C1, times e to the power of -1 second times x, times the cosine of square root of 3 over 2 times x, plus another constant, let's name it C2, times e to the power of -1 second times x, times sine of square root of 3 over 2 times x. You can notice that we have -1 second in the power of the exponent, which is the real part of our characteristic roots, and the imaginary part goes inside the trig functions, square root of 3 over 2. So let me pull it to the top. Let's make it red as well. Y sub 0 equals C1 times e to the power of -1/2 times x times the cosine of square root of 3 over 2 times x, plus C2 times e to the power of -1/2 times x times the sine of square root of 3 over 2 times x. So the first step is complete. Let's move on to the second one and find the particular solution of the given non-homogeneous equation. And to do this, we need to take a close look at the right-hand side of this equation. And we have the non-homogeneous term, let's name it g of x, equal to sine squared of x. Or it can be reduced to 1/2 minus 1/2 times cosine of 2x. In general case, if this non-homogeneous term is given in the following form, p sub m of x times e to the power of alpha x times cosine of beta x, or g of x equal to p sub n of x times e to the power of alpha x times sine of beta x. So it may consist of the polynomial function, or the exponential function, or the trigonometric function, or the combination of them. In this case, the particular solution y sub p of x is found in the following form: x to the power of s times t sub n of x times e to the power of alpha x times cosine of beta x plus r sub n of x times e to the power of alpha x times sine of beta x, where p sub n of x, t sub n of x, and r sub n of x are the polynomial functions. T sub n of x can be expanded as a sub 0 plus a sub 1 times x to the first plus a sub 2 times x to the second plus plus a sub n times x to the nth, and r sub n to the of x is expanded as b sub 0 plus b sub 1 times x to the first plus b sub 2 times x to the second, and times plus b sub n times x to the nth. Okay. Before getting started with this, we need to take another close look at our g of x, non-homogeneous term, because we first of all need to form the expression which I'll write down in a moment. The expression alpha plus I times beta. So we have an alpha here and beta here, and substitute them in here and obtain such expression, and then compare it to the characteristic roots and see if they coincide or not. Because if they do, if this expression coincides with one of the characteristic terms, we must set this s, this small s right here, to 1. And if not, then we should set s to 0. That's a piece of information to remember. Then, if this non-homogeneous term can be presented as the sum if g of x is equal to the sum for I being equal from 1 to n of g sub y of x, where g sub I of x is either a polynomial or a trigonometrical or a exponential function, or the combination of them. We may split our original non-homogeneous equation into n equations and obtain n particular solutions to these equations. So in our case right here, we have g of x equal to 1 second minus 1 second times cosine of 2x. So this means that we can actually split it into equations. First of them being y double prime plus y prime plus y equal to 1 second. And another one is y double prime plus y prime plus y equals negative 1 second times cosine of 2x. And then solve each of them for the particular solution, and then, having done that, we need to add these solutions we're going to find solving these equations, and we're going to obtain, this way we're going to obtain the particular solution to the original equation. So, let's try and do that. First we're going to solve the first equation. Let this one be the first, this one be the second. So we go y double prime plus y prime plus y equals 1 second. Now we should form the alpha plus I beta expression and compare it to our characteristic roots we have over there. Obviously, in this particular case, we have 0 plus I times 0. So here we have alpha and beta equal to 0. So obviously this expression won't coincide with any of the characteristic roots. So we can, without hesitation, set S to be 0. And that's a relief. And we can find the particular solution of this non-homogeneous equation, y sub 1 of x, as a polynomial function of the 0th degree, because the non-homogeneous term here is the polynomial function of the 0th degree itself. So the polynomial function of the 0th degree is a constant, and to find it we need to substitute it into the equation. Let's see what happens. So to do this we need to find its first and second derivatives. I don't need this sign. But what I do need is the derivatives. So I go y sub 1 prime equals 0, because the first derivative of a constant is 0. And of course the second derivative is a 0 as well. So basically what we obtain is, I don't think we're going to need this anymore. So basically what we obtain is 0 plus 0 plus c equals 1/2. So c equals 1/2. And this is our first particular solution to this non-homogeneous equation. So y sub 1 of x equals 1 second. Now let's move on to this second equation. So this time we have y double prime plus y prime plus y equals -1 second times the cosine of 2x. Okay, again we're forming this expression, this alpha plus I beta. And for this case we have that it's equal to 0 plus I times 2. So we have beta equal to 2. So this means that this expression doesn't coincide with any of the characteristic roots as well as just as we had in our previous equation. So again, we're setting s to 0. And this particular solution to this non-homogeneous equation is found in the following form: y sub 2 of x equals let me write it step by step. T sub n of x times cosine of 2x, this is our beta right here, and plus r sub n of x times the sine of 2x. Now the polynomial function we have in the non-homogeneous term of the equation is a polynomial function of the 0th degree again. So this means that these t and r functions in the solution expression will be the polynomials of the 0th degree as well. So these are constants too. So let me just put them into this expression. So here we'll have constant a times the cosine of 2x, and here we'll have the constant b, which will be multiplied by the sine of 2x. Now we need to calculate these a and b coefficients, and to do this we're going to first need to find the derivatives of this particular solution. So we'll go y sub 2 prime equals negative 2a times sine of 2x plus 2b cosine of 2x. And we're also going to need the second derivative, so we go y sub 2 double prime equals negative 4a times the cosine of 2x minus 4b times the sine of 2x. Okay, I think I need more space. Where do I put it? Where do I put this whole thing? Okay. Okay, so let me just recall a couple of things. So we know that our particular solution will be found as a sum of y sub 1 of x and 1 sub 2 of x. And this one is already found and it's equal to 1/2, so I can write it down. 1/2 plus y sub 0 of x, sub 2, I'm sorry, of x. And this summand is the one we're calculating right now. Okay, so I'm erasing this first equation. We won't be needing it anymore. Okay, so now we'll substitute these expressions into our equation and see what happens. Y double prime. I'm sorry, I won't need to write this one more time, so I'm just writing here this expression for y double prime, and I'll go negative 4a times the cosine of 2x minus 4b times the sine of 2x, and then we should add the first derivative. So we go minus 2a sine of 2x plus 2b cosine of 2x, and now we need to add the y function. So we go plus a times the cosine of 2x plus b times the sine of 2x, and this whole thing is equal to negative 1/2 times the cosine of 2x. Let's now consider the coefficients standing next to the cosine and sine functions in both sides of this equation. So, next to the cosine of 2x, we have negative 4a plus 2b and plus a, and it's equal to negative 1/2. Next to the sine of 2x, we have negative 4b plus 2b, right, or not? No, it's not. Okay, again, negative 2b minus 2a plus b equals 0. Okay, and this is the system of two equations, out of which we'll find our a and b coefficients. Let's see. Here we have negative 3a plus 2b equals negative 1/2. And here we have negative 3b minus 2a equals 0. So we go negative 3b equals 2a, and b equals negative 2/3 a, and then we substitute this into the other equation. So we go negative 3a plus, and plus turns into minus, minus 4/3, I believe so. Am I right? I suppose I am. A equals negative 1/2. So we can divide the whole thing by negative 1 so that we get rid of the minus. And we go 9 a plus 4a over 3 equals 1/2, or 13a over 3 equals 1/2, or 26a equals 3, and finally a equals 3 over 26. This is our first coefficient. Let me put it somewhere here. So we have a equal to 3 over 26. And we know that b equals negative 2/3 times a, so we simply multiply negative 2/3 by 3 over 26. So we go negative 2/3 times 3 over 26, which is negative 1 over 13. So our b coefficient is negative 1 over 13. Now, as we can remember, the y sub 2 of x was written in the form a times cosine of 2x plus b times the sine of 2x. And now, as we found these a and b coefficients, we can substitute them into this expression. And so we go 3/26 times the cosine of 2x minus 1/13 times the sine of 2x. Now, as we found y sub 1 of x and y sub 2 of x, we can finally find the particular solution of the non-homogeneous equation we were given. So y sub p of x, which is equal to y sub 1 of x plus y sub 2 of x, is equal to 1/2, which we've found earlier, plus this expression right here, plus 3 over 26 times the cosine of 2x, and minus 1 over 13 times the sine of 2x. And that will be the end of the second step. Let me write it in the top and make it red as well. So y sub p equals 1/2 plus 3 over 26 times the cosine of 2x minus 1/13 times the sine, write it another way, sine of 2x, and that's it. Okay. And now, as we know the solution of the homogeneous equation corresponding to the given one and the particular solution of the given non-homogeneous equation, we can finally add them and write the whole solution to the original equation. So y, which is equal to y sub 0 plus y sub p, is equal to c1 times e to the power of negative 1/2 times x times the cosine of square root of 3 over 2 times x plus c 2 times e to the power of negative 1 second times x times the sine of square root of 3 over 2 times x, and plus this particular solution of the non-homogeneous equation, which is 1/2 plus 3 over 26 times the cosine of 2x minus 1 over 13 times the sine of 2x. Okay, and now we should probably apply the initial conditions we were given. So we go substituting 0 into this expression instead of each x, and see if we can find any constants. And we only now need to find these two little constants. Okay, so we go as follows. C1 times e to the power of negative 1/2 times 0 multiplied by the cosine of square root of 3 over 2 times 0 plus c2 times e to the power of negative 1/2 times 0 times the sine of square root of 3 over 2 times 0 plus 1/2 plus 3 over 26 times the cosine of 2 times 0 minus 1 over 13 times sine of 2 times 0. Now let's see. Anything raised to the 0th power becomes simply 1. Then cosine of 0, I'm sorry, is equal to 1. Sine of 0 turns to 0, so this whole summand turns to 0. Then we have the cosine of 0 again, so this multiplier is equal to 0, and this whole thing is equal to 0 again. Okay. Now let's see what's left. And what we have is C1 times 1 times 1 equals simply C1. This equals 0, then we have 1 second. Then we have 3 over 26 times 1, which is 3/26. And that's it. And according to the statement, this whole thing is equal to 1. And so we obtain an equation which we can solve for C1 and obtain this constant. So let me just write it someplace more convenient. So out of this equation right there, we have C1 equal to 1 minus 1/2 and minus 3/26. Which is 1/2 minus 3 over 26. This one goes multiplied by 13, so we have 13 minus 3 over 26, or 10 over 26, or 5/13. So this is our first constant, which can be substituted into this residual expression. To find the second constant, we're gonna need to apply the second condition, and to do this we're gonna need to find the expression's first derivative. So let's go. Y prime of x is equal to 5/13 times negative 1 second times e to the power of negative 1 second x times the cosine of square root of 3/2 times x. Then plus 5/13 plus turns into minus 5/13 times the square root of 3/2 times e to the power of negative 1 second times x, and times the sine of square root of 3/2 x. Then we have plus minus 1 second times c2 times e to the power of negative 1 second times x times sine square root of 3/2 x plus square root of 3/2 times c2 times e to the power of negative 1/2 times x times the cosine of square root of 3/2 times x. The first derivative of a constant equals 0. The first derivative of the cosine function is the negative sine function, so we go minus 3/13 times sine of 2x, and finally we have minus 2/13 times the cosine of 2x. And that's about it. And now, applying the second condition, we substitute 0 into this expression instead of each x. So here we have times 0 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 here and here. Now here equals 1. This equals 1 either. This whole thing equals 0 because the sign of 0 equals 0. Then this multiplier equals 1, which is not important because the whole summand equals 0 because of the sine function again. Then this multiplier equals 1, this equals 1, this equals 0, and this equals 1. So let me just write the numbers instead of all of these things. So this thing is going to multiply by 1 instead of the exponential function, and by 1 instead of the cosine function. This one goes away. Because it's equal to 0, this one is gone as well. Then we have this square root of 3 times C2 times 1 and times 1 instead of this summand. This next one goes away again because of the sine function. But this negative last one stays. Minus 2 over 15 times 1. So we have negative 5 over 26 plus square root of 3 over 2 times the C2 constant, and minus 2 over 13, which is equal to square root of 3 over 2 times the C2 constant. This goes multiplied by 2, so we'll have minus 9 over 26. Right. And according to the statement, this first derivative at the point x equals 0 is equal to negative 9 over 2. So again, we have another equation out of which we'll find another constant C2. Just put this constant into this red expression so that it won't get lost. 5 over 15. So this is the C1 constant we've calculated earlier. And here's our new equation. Square root of 3 over 2 times C2 constant minus 9 over 26 equals negative 9 over 2. So we have square root of 3 over 2 times C2 equals negative 9 over 2 plus 9 over 26. This thing goes multiplied by 13, so we have negative 20, 9 times 13 is 108, I believe. 100 and... why not? No, it's not. Again, let me check myself. 9 times 13, so it's 90 plus 27, so it's 117. Okay. So we have negative 117 plus 9 over 26, which now is equal to negative 108 over 26, or negative 54 over 13, I believe so. Okay, and C2 constant is equal to negative 54 over 13 times 2 divided by square root of 3, which is equal to negative 108 over 13 times the square root of 3. So this is the constant. We'll substitute into the expression above. I'll try to squeeze it in here. So since the constant is a negative number, this plus right here turns to minus. And here we have 108 divided by 13 times the square root of 3 multiplied by the whole thing, by e and the sign. So finally, we can now write down the solution to the whole original equation by adding these two, y sub 0 and y sub b. We've waited a long time for this. So y, which is equal to y sub 0 plus y sub b, is equal to 5/13 times e to the power of negative 1/2 times x times the cosine of square root of 3 over 2 times x minus 108 over 13 times square root of 3 multiplied by e to the power of negative 1/2 times x times the sine of square root of 3 over 2 times x. And then we add the particular solution to the non-homogeneous equation. So we go plus 1/2 plus 3 over 26 times the cosine of 2x and minus 1 over 13 times the sine of 2x. And this is finally the answer to our differential equation.